D2 Mathematics, Chapter 13, it's about symmetry of shapes. So let's do challenge yourself of Chapter 13. So we are given two problems over here. Both problems have same task to do. How many planes of symmetries are there for this 3D shape? And what is a rotational symmetry, axis of rotational symmetry? So we are given like cylinder and a hemisphere on it. In the other part, this is cone and hemisphere of it. So both are similar problems. So before we solve this problem to find planes of symmetry, quickly recall what is symmetry. When we are given a square shape, so lines of symmetry are those lines across which the shape behaves exactly symmetric behavior. So for example, for square, we can have a vertical line of symmetry or a horizontal line of symmetry. S Similarly, we can draw diagonal across the diagonal. So we will have symmetric triangles up and down. We can draw other diagonal and we will have symmetric shape. So we can have four lines of symmetry for square. For rectangle, we have two lines of symmetries. So be careful, there are not four lines of symmetries for rectangle. We have two lines of symmetries. One is vertical and the other is horizontal. Diagonal cannot be line of symmetry for rectangle because for line of symmetry, if you fold the shape across line of symmetry, one part should lie exactly on top of other. So over here, if you fold it, it won't be lying on top of the others. You can easily visualize it. Take any A4 paper, rectangular paper, and fold it across the diagonal. So you will see it will not lie exactly on top of the other part. So over here we are given we have shown two more shapes, stars. So we can have vertical line of symmetry, horizontal line of symmetry, and then we can have these diagonal lines of symmetries. This shape has two lines of symmetry, vertical and horizontal. When we are going to have 3D shapes, for example, a cube, then we have planes of symmetry. Over here, we can see for cube, we have just dissect cube into half from horizontal perspective, vertical perspective, or we can say like from the third dimension. So we have three planes of symmetries like this when it is cutting into two parts, front and back, or right or left, or up or down. Then we can have diagonal planes of symmetry. So we can put along the diagonal from one vertex to the other vertex plane of symmetry, and then similarly we can do it for the other diagonal plane of symmetry. So we have got 3 plus 2, 5 planes of symmetry, and then we can have a diagonal plane starting from one edge to the other edge, one top edge and corresponding opposite edge at the bottom. So we can have one line of symmetry, a plane of symmetry like this. Just bring this edge to this one and the bottom edge goes to the other bottom edge. So we get this plane of symmetry and then change its direction, orientation. So we start from this side edge going to the bottom side edge and just bring it on this edge and the bottom edge goes to that edge. So we'll get this plane of symmetry. For cube, we have 9 planes of symmetry. So if we are going to have some other shapes, then we can think about how many lines of symmetry we will have. For example, if for a sphere, how many lines of symmetries will be there? If we rotate a sphere, so I am just going to draw a circle, but you can think about a sphere. How many lines of symmetries we are going to have? Even for a circle, how many lines of symmetries we are going to have? There will be infinite line of symmetries. A symmetric across this, symmetric across this. It would be better if I draw a proper circle like this. So we can have infinite lines of symmetry. So wherever we draw a line as diameter, so we are going to have any diameter is going to be a line of symmetry. As long as it is passing through the center, so it's line of symmetry, because any diameter is dissecting circle into two halves. Then comes rotational symmetry. So for rotational symmetry, so we call it order of rotational symmetry, like how many times it will turn back to its original shape if we can do complete rotation. For example, for scale, so if we rotate it 90 degree, so this is our reference point E. So if we rotate it 90 degree, we still have got the same shape. Again, if we rotate 90 degree, we still get the same shape. So if 4 times we are going to rotate, we will get the same shape. So this is first rotation, this is second rotation, third and fourth rotation. So rotational symmetry or order of rotational symmetry for sphere is 4. This is hexagon, so we can say a regular hexagon which has same sides, all 6 sides are of same length. So we are going to have 6 rotational symmetries. So 6 times if we keep on rotating till we come back to our original point. So let's call it like A. So A, when it's going to be rotated 6 times, so we'll always have a same kind of shape as original till point A comes back to its original position. So order of rotation symmetry for hexagon, a regular hexagon, it's 6. For 3D shapes, again, we can define order of rotation symmetry, and we can also define axis of rotation symmetry. So for a cylinder, so if we draw a vertical line passing through the center of cylinder, so that is its axis of rotational symmetry. For sphere, we can think how many axes of rotational symmetries are there. There will be infinite, because wherever we draw a diameter, send any line passing through the center, so that will be its axis of rotational symmetry. That was a quick recall about symmetry. Let's solve this problem. Now, this problem is quite easy. The figure below shows a solid made up of a hemisphere and a cylinder, which share a common base. How many planes of symmetries are there? So plane of symmetries, wherever we draw, so it will be a plane of symmetry, as long as it is passing through the center. So this you can imagine it in like 3D. So if we keep on rotating this plane, so we are going to have plane of symmetry. So there will be infinite planes of symmetry. Planes of symmetry. Planes of symmetry. That is because of its circular nature, uniform circular nature. So next part is draw the axis of rotational symmetry. Now this has become easy. Draw axis of rotational symmetry. It is just a line, vertical line passing through the center of cylinder. So this is its axis of rotational symmetry. Around this axis, if we are going to rotate the shape, we will always get the same shape. So question number 2, exactly the same tasks, but for a different shape. So this shape is an ice cream cone made up of a hemisphere and a cone at the bottom. So how many lines of symmetries does this have? Again, because of its symmetric nature, circular nature, so we are going to have infinite planes of symmetry. So if I draw this as center of the plane and this in 3D, I'm trying to draw. So if this plane we keep on rotating in this shape, as long as its central line, vertical line is passing through the center of this shape, so this is going to be a plane of symmetry. So again, we are going to have infinite planes of symmetries. Infinite planes of symmetry. Planes of symmetry. And part 2 is draw the axis of rotational symmetry. Just like before, we can draw a vertical straight line going through its center, exactly through the center. So this is axis of rotational symmetry. Around this axis, if we are going to rotate the shape, so it will always have same symmetry across this shape.